Hello again. We carry on with our tech journey and we welcome on stage Natalie Godec. Natalie is a woman tech maker ambassador. She's also GD for cloud platform, but today she will be talking about serverless application with a focus on security. So please give a warm welcome to Natalie Godec.
Hello, everybody. Welcome to this session where we are going to be talking about security in serverless and all of the myths and the pitfalls which you can fall into when working with serverless technologies. My name is Natalie Godec. I'm a cloud/platform/DevOps/systems engineer, or whatever the name of this job, the trendy name of this job, is in the next 6 months. And currently, I'm architecting clouds at Zencore. Zencore is a tiny boutique Google Cloud partner consultancy. We build cloud platforms on Google Cloud for other companies. And we do real engineering and real architecture work to really help people drive value out of all of the wonderful and shiny cloud services. My real thing is infrastructure and everything that is related to data and security. And I'm also a photographer, and you can find me on socials at @uvisfeed. And that QR code is the feedback for the session. The organizers of DevFest Nantes encourage you to leave feedback for all of the sessions that you go to. So let's dive in. This is an example of a driving license in Australia. And this is an email that the residents of the Victoria state in Australia received from their government, informing them that their licenses will need to be reissued following a data breach of Optus. Optus is the biggest telco in Australia, and a couple of years ago, 10 million customers' data was breached. The population of Australia is 25 million. 10 million of them lost their personally identifiable information. How did that happen? That's such a huge thing, right? Must have been some huge hacking group, maybe state-sponsored, right? Maybe some serious operation, right? No. Some dude just found an API and downloaded the data. And this is a screenshot from the hacking forum where journalist Jeremy Kirk was asking the person who claimed to be behind the hack, what did he do? And he said, well, I found this API, the address was a bit weird, but I connected to it and found all of the data. What, just like that? And he confirms, yeah, no authentication. So people say that Optus wasn't actually hacked. Optus just put their customers' data out on the internet. We don't know what infrastructure was behind this API in Optus. But it's really easy to imagine that if you are experimenting with something and you want to put out an API and it's a quick little script, you package it into a Docker container and you just throw it in the cloud. And you have an API. Really easy. With serverless tech, even more easy. What do we mean when we say serverless tech? Most commonly, it's compute. I will be using examples from AWS and Google Cloud in this talk because I am mostly familiar with those. So compute, we have functions, Lambda or Cloud Functions. We have the ability to throw a container in the cloud with Fargate or Cloud Run. But also we have serverless databases. This is when you can store data in a database, but you don't actually have an instance, you don't have an IP address, it's not in your network, you don't control the hardware, virtual hardware of your database. Aurora in AlloyDB, DynamoDB, and Bigtable. But also, like, data products in a bigger sense, right? We have everything that is around streaming, topics, ingestion of events. We have block storage, object storage in S3 and storage. We have BigQuery, we have Glue, we have all of those analytics tools. Those are also serverless. When we usually talk about serverless, we only mean compute, but it's actually a lot more than that. But in this talk, we will focus on compute. You could do all of the things, right? Like I said, you have so many different products. And now, when I go to potential clients and they want some sort of ability to run a workload in the cloud and transform some data maybe and store that data somewhere, my natural instinct is to ask if they would consider serverless. Because I don't want to manage networks. I spent 7 years studying networks, but I don't want to manage them. I don't want to manage instances. I don't want to think about ports and firewall rules and all of that stuff. If you do serverless, it's a lot easier and it's a lot cheaper. But ports and firewall rules and networks allow us to understand how the security works of our workloads. Not in serverless. How do you do that in serverless? In serverless, you have 3 main components. One is in-app security, meaning your code needs to be aware of the requests that are coming in and maybe authenticate. If you went to the AWS Vulnerabilities workshop yesterday, there were a couple of those cases there where there was no security in the code, there was no kind of data cleaning and input masking and whatnot, and there wasn't any authentication. So that's your in-app, in-code security measures. And then you have who has access to the service and what the service has access to. And those are the 2 things that we will focus on today. Starting with, what does the service have access to? The developer of the Optus API, who just put 10 million people's data, including their driving licenses, out to the internet, must have thought, oh, it's not connected to anything, it's just an experiment. I'm not going to think about authentication of this API. I'm just developing, I'll leave it there. And it's really, really easy to make the same mistake. As an example, we will take Cloud Run in Google Cloud and Lambda in AWS. What I mean by what does the service have access to? Well, as an example, your service might want to read some events from a queue, PubSub or SQS, write some other events into a different queue, again, PubSub or SQS, read and write data from some database, and obviously write logs. Those services is what your service has access to, what your workload has access to. By default, you have things that can be misconfigured. In GCP, it's default service accounts. These are the identities that are created by default by Google in your project and given a specific set of roles. Very often, those roles are way too open. For example, a very popular and very famous service account is compute. It's used by Compute Engine, it's used by Kubernetes, it's used by Cloud Run, and Composer as well. It has editor access to the project, meaning read and write on all of the resources in the project. If you're more familiar with AWS, a project is like an AWS account. So you can imagine that you can have all sorts of things in your production project. Meaning that if you have data in BigQuery, sensitive data, customer data, and you have raw data in cloud storage, and maybe some reports as well, and you have events going in all directions in PubSub, well, guess what? That default service account has access to all of that. And if you leave a vulnerability in your Cloud Run service, in your code, a potential attacker can get access, read and write, to all of those resources. So what do? You create special service accounts, ideally for each of your workloads, and you give them really specific roles. This sounds trivial, but you will be really surprised. So now if you create a service account for your workload, and you give it storage object creator role for a specific bucket, like bucket ABC, for example, and you give it PubSub publisher for PubSub to exchange events, to write events into topics. Now, you no longer have access to BigQuery. So your customer sensitive data is safe. Same situation in AWS. You have default AWS policies that are created and managed by AWS. They are called this way, AWS managed. There's more than 1,000 of them, and they often have way too open permissions. For example, AWS Lambda Execute has S3 read and write on all S3 buckets. So if you or one of your developers is trying to do like a little Lambda and very quickly, click, click, click. Oh, I need a policy. Oh, I need a role. Is there a default policy? I want that Lambda to execute. This is called Lambda execute. I'm going to use that. All of a sudden, your Lambda has access to all of the data in your S3 buckets in this account. Someone told me yesterday that this is an old AWS policy, which is good news. AWS is learning from their own mistakes. But if you don't know that it's an old policy, the name suggests that you can use it. How to fix that? Of course, you create special policies, ideally, again, for each Lambda, or maybe you can group your workloads into buckets, not storage buckets, but workloads, like environments or maybe like use cases, and create specific policies for those use cases. In this case, for example, you say that this particular function has get object and put object in this specific bucket. That's it. Now, if an attacker gains access to your Lambda and injects some reverse shell into it, they can only get access to this bucket. And if your Lambda is serving kitten photos, then the only thing the attacker will see is kitten photos. The next thing is static tokens, the worst nightmare of every SecOps engineer. In GCP, this is IAM service account keys. In AWS, it's access keys and secret keys. And they are very, very, very easy to create and start using, right? And to share as well. You just copy that, stick it into a secret somewhere, done. Really easy to steal as well. And if you look up vulnerabilities in Lambda, you will see that most of them are exploitable via stolen keys. So there you go. And in the words of Google, to bad actors, service account keys can be even more valuable than a leaked password. Why is that? Well, when do we use these keys and service accounts and exchange of credentials like that? Most cases in pipelines. Most cases, if you have your Terraform applying, your agent applying, modifying your infrastructure, that identity will have really high privileges. And you might use service account keys. I used them in the past as well. But they're really easy to steal, and now the attacker has admin access, root access to your infrastructure. Really not good. Why is all of this important? Let's have a look. We're talking identity, we're talking about IAM permissions. Why is all of that important? I have a little web app. This is Streamlit. Streamlit is a Python library for serving data-focused applications. And what do we have here? We have BigQuery, SQL Explorer. OK, this is probably serving some sort of data sets. And there are data sets here, clients redacted, and connections. OK, cool. Clients redacted. Interesting choice of name for a data set. And the UI is suggesting that you run this query first to see what is the available tables, what are the available tables in this data set. We have clients. OK. What if I select star? OK, I have much more information. And I can do this by just knowing how BigQuery works. And typically, this would be like you want to give some analysts access to some sort of data, to some subset of data, but not to all data, right? So you've run this query, and you actually have the project name here. This is my sandbox, cool. The data set is clients redacted, and the table name is clients. What if I know how BigQuery works, and I have a little query here that will allow me to list all of the data sets in this project, in my sandbox. Now, ideally, since we have a select dataset drop-down here, you would think that this app would allow access to only those datasets, but maybe it doesn't. Maybe the person who developed this web app actually used the default service account. Cool. I see all of the other datasets, and one of them is clients raw. OK, that gets more interesting. But since we are not like this query is telling us to just query directly, And I think it's doing some sort of substitution, like it's telling the BigQuery API to query the selected data set. But what if I can override it? Maybe I can override it. Let's see. Again, I know how BigQuery is structured, the SQL language of BigQuery. So I can say project name, dataset name, and this is the standard, like, give me all the tables. Let's see. And this is client's raw, right? And my selected dataset is client's redacted. Can I override that? Yes, I can. Turns out this app has much wider permissions than it should. It should only give access to these two datasets, but it doesn't. OK. We have client data table. OK. Now, what if we did select star from this, and client data? So this should ask for all of the information that is stored in that table. I shouldn't have access to this, because I only have access to two data sets. But I do. And this table has names, dates of birth, social security number, home address, everything that you need to do to fake someone's identity. This is typically what will happen if you use a default setting that is available in the Cloud Console, or the default CLI command, or the default Terraform configuration. These security measures that are supposed to be built in are not. The cloud is structured in a way that allows you to experiment really, really, really quickly, but the security, you need to think about that. And now you know. What else can we do? What about who has access to the service? Why, in the first place, was I able to access that UI and exploit what kind of data sets exist in that project? It's all about invocation roles, right? Your workloads, your serverless workloads, are just endpoints in the internet. Whether you like it or not, it's just an endpoint of the API. So you need to restrict who can launch them. And of course, sometimes you will want that web app to be public, but sometimes you wouldn't. And you might want to restrict the Lambda invocation to a specific role. Does this work? Yes. So to a specific role in AWS, and only to the specific function, so that not everyone can launch that function. And the way serverless works, right? You don't have a constantly running workload. You need to invoke the workload first, and then it will appear, and the compute resources will be provisioned. So the invocation role is the most important. And then in GCP as well, you have the invoker role, and you might want to restrict that to a specific service account. In the demo, it's a user-facing web app, data science web app, but very often Cloud Run is used for things like transferring some data, or transmitting, or changing something, writing a record somewhere, some kind of not very compute-heavy workload. And often we have pipelines and different Cloud Run services that interact. And since we have learned that we need a service account per workload, dedicated service account, we can say that this specific function, my service, is only allowed to be invoked by this identity. And maybe this identity is run by another Cloud Run workload, or another function, or Gkey, or something like that. You limit access to who can even launch that workload. That's half of the way, right? But you don't want to do that. You want to just click ops things. Click, click, click in the console. I'll just do it. But it's internet access of things, because everything is a cloud API. Everything is an open API. For Cloud Run, in terms of limiting web access, you can do things like checking the incoming request. And serverless is not really serverless. It still runs on some sort of computer somewhere else. It still runs in some sort of network somewhere else. You just don't have access to it. So a user goes to a specific API or a specific DNS address, Cloud DNS points to it, and then the cloud can check, can this user invoke this service? If you had left the policy for invocation of Cloud Run open to all users, then there might not be any authentication even. But if you restrict it to a specific identity or a specific role, this will be checked. The identity of this user will be checked. But what if you do need to make it public, but you still want authentication and authorization? In that case, you have identity-aware proxy. This sits in front of your Cloud Run and in front of a load balancer. You do need a load balancer for this. You don't need a load balancer for Cloud Run to function itself, but for identity-aware proxy, you do. And so this acts as a front end in front of your app, so that BigQuery SQL Explorer that I had in the demo could have had an identity-aware proxy in front of it that would have forced me to log in, and that would have checked whether or not I'm allowed to access this service. It's integrated with Google Workspace and Cloud IAM, which is really handy. Typically, you would use this for an internal authentication. So like you want to give a specific team of analysts access to that web app, and you would say that in the identity-aware proxy, you would say that that specific group, that specific team is allowed to use this service. So it would check and it would do authorization for you as well. And it's available for Cloud Run, App Engine, Gkey, Kubernetes, and Compute Engine. Really handy. In Lambda, you would also need something in front of the Lambda in order to provide security. And typically, this would be an API gateway. And if you ask your friends whether or not they have ever had a data breach related to Lambda, they will probably tell you that it was because they forgot to put in an API gateway. But an API gateway is a big, heavy thing. You might not want to have to do a full-on, full-blown API gateway. Maybe you just want a single API that is connected to everything because you didn't do a specific policy. Now, you can have Lambda function URLs. You don't need an API gateway. AWS provides a URL for your Lambda, like a web-facing, public-facing URL, publicly accessible URL for your Lambda. Really handy. You don't need to do API gateways anymore. By default, the URL will have authentication type none. Great. Lambda does not perform any authentication. Choose this option if you want public unauthenticated access for your function URL. But is it the default option? Yes, it says that with that you also need a resource policy that allows unauthenticated access. And guess what? That's what the resource policy looks like with the unauthenticated access. Use for Lambda function URLs, but change the authentication type. But again, if you're just experimenting, or like you're a developer who doesn't really know about security, it's really easy to overlook these things. You wouldn't even think about, okay, it's a URL, is there authentication on it? That kind of thing. You can also write policies that restrict network access. And again, serverless doesn't have network in your VPC in the traditional term and in traditional meaning of it, which means that it doesn't run within your VPC unless you configure it specifically, and I'm going to touch on that later. But you can do this identity-aware proxy and load balancing. And what you see here is a URL for, can you note? Yes. The URL for the Run app itself. So your Cloud Run app, your Cloud Run workload will always have a URL, like the Lambda function URL. But you can put DNS and a load balancer in front of it, stick up a certificate into it, and identity-aware proxy. And now you have a fully formed, like myservice.example.com, a proper URL, not a Google-generated .run.app thingy. So what are we doing here? We are making sure that people are accessing the URL and not the service directly. But what if someone finds or guesses the default Cloud Run URL, the one that I was also accessing in my demo? Well, by default, the ingress setting is allow all traffic, meaning that someone, a threat actor, finds out the URL of your service that is not the myserviceexample.com, but the auto-generated Cloud Run URL, and they can access it, bypassing your certificates, bypassing your traffic checks on the load balancer, bypassing your identity-aware proxy. That's the default setting, but you can control it. So if you do identity-aware proxy and load balancers, make sure that you change it to ingress traffic internal load balancer. There is a third setting called ingress internal only, which means that it only allows access from the same project, the same VPC. So in this setting, an attacker who finds out the URL of your service will not be able to access it because the traffic will now come from the outside and not from the load balancer. They cannot access it. They will have to go through identity-aware proxy, which will check the identity of the caller and perform authorization. And of course, it's a threat actor, so they will not be allowed. Happy days. You might think it should all come readily configurable, readily configured, and all of those security measures should be already there. Well, they aren't. But again, we're learning, we're seeing things that we can do to make the serverless workloads secure, even if you're just doing experiments. I mentioned before cloud services are public APIs. Every data set, every database, every Lambda function, every Cloud Run service is just an endpoint on the cloud API. And you really do need to think about securing them. And serverless is, of course, not really serverless. And by that, I mean functions in Cloud Run, for example, in GCP, they run in parallel with your project. You deploy them in your project, but actually they are in a different place. But they look like they are in your project. Sometimes these projects are called shadow projects. They exist in parallel with yours, and they are yours, but you will never see them or have access to them. And that's really tricky to debug and see where things are coming from. But if you do want your service to be in your VPC, which is not exactly trivial, right? We're talking serverless. There shouldn't be network. But if you do want it to appear in your network and have a private IP address, then you can use a serverless VPC connector. You create it in your subnet, and you connect the function, for example, to the VPC connector, and now it has a private IP address within your private subnet, and all of the communication that the function will be doing to BigQuery or VPC-hosted services, your VMs, your instances, will go through private networking, will be in your VPC. For other things that are serverless, like data stores, you will need to do some other things like VPC service controls, private service access. But this serverless VPC connector allows the compute runtimes, serverless compute runtimes, to have a private IP address. Cloud Run now has native VPC egress, which means that you don't actually need a VPC connector anymore. It only works for egress, meaning that Cloud Run can access things in your project, in your VPC privately, but if an instance calls a Cloud Run service, then it wouldn't be able to, because ingress is not the same thing. So it's only for egress, but really handy as well. Same for AWS. If you have some services that are running in a subnet, in a VPC, and they are communicating with S3 or DynamoDB or like Lambdas and CloudWatch, AWS will do their best to keep that communication within AWS backbone, but it does sometimes go out to the internet and then back into the AWS backbone. Why? You know. But you can make this communication private as well, and you can force it to stay within your VPC using VPC endpoints for storage, for Lambda, for CloudWatch, all of those things. In that case, you do need to provide routing for the subnets to know where to route the requests to those services, like via the VPC endpoint, but then the communication will stay within the VPC, no longer going out of AWS backbone. And the last thing that I really like ending my security talks on is restrict public access to your buckets. This is a screenshot from a service that I found by just Googling AWS public buckets. And we see 308,000 AWS buckets, that's 3 buckets, open, 95,000 Azure, and 106,000 GCP. This was taken about a month ago, so, oh, last update, 6th of January, okay, yeah, so this is still relevant. This is a publicly accessible buckets. Some of them are meant to be, some of them are serving kitten photos, but I don't think all of them are serving kitten photos. And this is a recording of me going to that Googleable service. You can also Google it. And looking for files. You can do this too. You can go and Google and find files. And let's actually make this. Let's do this. I still have it probably in the history. But if you just Google AWS publicly accessible buckets, you will find it too. So yeah, there we are. And we can search for keywords. The keywords will search for names of files. My favorite thing to search for is credentials. And I've already searched for this. What do you think will happen? Or we'll find files that are called credentials. Custom API user credentials. That's an image. PDFs. That looks suspicious. There are tons and tons and tons and tons of them. And these are public buckets, so that means that you can go and download these files and use them. Another thing that I really like looking for is encryption keys. So IDRSA is a very common name for encryption keys. And we can find those as well. Some of them are .pub, which is public keys, which is great. But some of them are not. This is not a public key. And this is not a public key. And last time I looked, they were, yeah, there you are. .ssh, IDRSA, that's someone's SSH key. Anyone wants to look for something specific? For a name of the file, their last name? Don't be shy. Or are you Googling on your phone already? Anyway, that's that. Please close access to your public buckets because they are out there on the internet, ready for use. You can do this on like per bucket level, of course, but also you can have an organization policy that restricts opening buckets to be public. You have, in AWS and GCP, you have the same organization policy, restrict public access to the buckets. And then if you do need a bucket to be open, you do need to serve those kitten photos, then you go and specifically exempt that bucket or that project or that account. Because that's now your public resources, you're publicly accessible, and you know that it is. Otherwise, people will put their SSH keys on the internet together with pushing credentials up to GitHub. But you can prevent that. And with that, I thank you very much for your attention. Merci beaucoup. I can answer questions.